Hello everyone and welcome to Depth First. In this video, we'll try to understand the inner workings of a singly linked list. A linked list is a fundamental data structure that enables you to store a sequence of objects in a specific order. Now these could be numbers, strings, or custom objects. It also allows you to traverse them in the same order. In contrast to an array which have a fixed length and cannot have elements dynamically added, linked lists are dynamic in nature. This makes the linked list a better choice if you do not know in advance how many elements you need to store. Another difference is that the linear order of elements in the array is determined by their index within the array. In a linked list, the order of elements is determined by a reference that exists within each object. I'll provide further clarification in the upcoming slides. Each object in a linked list is called a node or a list node. That's how we implement a list node. It has a value and a variable called next. And that's what a linked list looks like. A given node's next variable refers to its successor in the list. The list's initial node is called the head. When defining a problem involving a linked list, the head of the list is typically provided. If the value of the head is none, then the list is empty. If a node's next variable is none, then the node has no successor and is considered the last element of the list. It's also known as the tail, which in this case is node 5. We'll be exploring some operations that can be performed on a list, such as append to a list, length of a list, search for the first instance of a specific value, and delete the first occurrence of a value. To facilitate understanding, I'll construct a linked list class and add these functions to them. Our first function to examine is append, which adds a new node to the list. We've already discussed the list node. Here is our implementation of a linked list class. The self.head attribute is initialized as none. Regarding the append operation, the initial step is to verify whether a head node exists. If not, we must create one to serve as the first node in the list. For subsequent appends, we'll create a variable called cur and assign it the value of self.head. We'll traverse cur to the last node in the list, to which we will append the new node. Let's now discuss the time and space complexity of the append function. For each append, we enumerate to the end of the list. Let's consider that the list has n elements. Therefore, the time complexity is O of n. The space allocation, however, does not correlate to the number of elements in the list. For every append, all we do is allocate a new list node, thereby giving us a constant space complexity. Moving on, let's go over how to find the length of the linked list. To find the length, we will utilize the cur variable once again to traverse the list until it is not none. We will increment a count variable as we traverse and return that as length. The time complexity of finding length is also O of n, and the space complexity is O of 1 or constant. Let's now examine the search function. The search function is responsible for locating the first node in the list whose value is equal to the specified key. Notice how it uses the cur variable again to traverse the list until it finds the matching value or until the end of the list is reached. If no element with the specified key is found in the list, the function returns none. Again, similar time and space complexity as the other functions that we just reviewed. Let's take a look at the delete function as our final point of examination. In the case where the node to be deleted is the head node, we will change the head to point to its next node and return from there. Otherwise, we will traverse the list to find the node to be deleted while keeping track of the previous node. This is done so that once we locate the node to be deleted, we can update the previous node to point to the next element of the current node. By doing so, we remove the node to be deleted from the list. So that's your linked list data structure. You should now be equipped to tackle problems related to a singly linked list, and I have listed some of them in the description below. I've also provided a link to the GitHub repository containing all the code that we just discussed so that you can try it on your own. Thank you for taking the time to watch this video. If you have any questions or suggestions, please feel free to leave them in the comments section. I'll try my best to respond to them. If you found this video helpful, please consider giving it a like, subscribing to my channel, and sharing it with others. Thank you.